Alright, I left you last time with a lot of syntax errors. As a beginner, don't freak out when you see a bunch of compiler errors. Usually it's just something simple. In this case it was, well, when I did my define statements, I defined, chip enable 1, chip enable 0, and A2, A1. I put an OS in front of this, the letters OS, and a slash, and then when I wrote them in to my method, I didn't include the OS's. I've corrected them here, and so that was causing compiler error. So obviously when I define something, I need to use it properly, just the way I type it out when I write it, use it in a method, in a function. Anywhere in a program, I need it to write it the same way that I defined it, which I didn't do, so it gave me those errors. So I corrected that. And I made a couple changes to the schematic. I added a LED to pin 6 on port D. It's going to make a little heartbeat function. I like to, just as a troubleshooting method, I like to make sure that I'm actually programming when I flash the chip, that I'm actually, it's actually getting into the chip. It's being flashed properly. So even if your main program doesn't work, you write a little test program on the side, a little test method. They'll flash the LED a couple times. Then I know at least that the program's getting flashed into the chip, and that part's working okay. And then I can go on to the rest of my program and find out where the problem is there. And one other thing I made, added, instead of wiring the read pin to the power rail, decided to just connect it to one of the pins, pin 6 on port A, and write it high. And like I said, I just try to keep things real simple. If I think there's gonna be a problem or something I'm unsure of, I'll start out from where something I've done before that I know that works, just to eliminate all the errors. Okay, so I added the read pin, so I need to define it. And that's pin 6. And I need to add it into my method. So we're going to pull it high. Okay, so we're going to enable the chip and then put in a small delay, and then pull the read pin high, and we're going to write to that first digit to the farthest to the right. And because I added a new pin here, I need to make sure that it's an output, define or set it as an output. I've already set my A port to output, so when I added the read pin to it, it's already set, because I set the whole port to output. So I'm just using that last unused pin in the port A, so I don't need to set that, it's already set here. But I'm only using one pin in port D, so I need to set that one pin to an output. So the data direction register for port D, and I'm only going to set one pin, that one pin, pin 6. Okay, now I've set it to an output. And now let's write a little function for that, a little test function, that heartbeat. And I will call it my test. Has no return, no input parameter. And I'm just going to set up a little for loop. Don't forget to make your delays long enough so that the human eye can pick them up. You make them too short and you won't see any flashing, or sometimes you won't see your LED come on. So basically I'm just going to have this LED come on, flash a couple of times before I write a character to the OSRAM display, just to make just like I said, making sure that that I'm flashing the chip properly. And so that should be it for the little test function. Alright, for the OSRAM display we've got the method set up, and I'm going to basically, another precaution is reset the pin before I write to the display. Correction, reset the display before I write to the display. So I'm going to bring the reset pin low. And that is on our auxiliary port. Where was our reset? Up here. OS reset. Alright, so brought the reset pin low here. And gonna add a little delay. we're going to put in 220 milliseconds, which is probably way too long. But we'll give it a shot. I tend to go high first, and then if it works, then I'll bring it down, step it down to, you know, as short as I can get it, and well, let it still function. So I'm going to bring the reset pin back high after bringing it low. Alright, so that should take it. Now I could write this in a little function too, and probably should, but right now for testing I'm leaving it out here. And as soon as we can see we get it running. Once you get it running, then you can start cleaning up your code and playing around with it. But then at least you know you have all the basic functioning working, and then you can play from there. Now we've written the write function to the display, but with the OSRAM display, you also need to set the brightness. I made that mistake initially. I'd wrote a write function, and then I'd write it to it, and it wouldn't work, and I thought there was something wrong. I was writing the write function wrong, and what I had overlooked was you need to set the brightness. So I was actually writing to the display okay, but it wasn't showing up because I hadn't have the brightness on the display up. I had it to 0. It looked like the chip wasn't even working. And you do that through a control word in the display, and to access the control words, you need to basically, it's almost identical to the write function, except you're going to bring the A2 pin, you bring it low, and that signals to the OSRAM display that you're writing a control word to the display. And then once the A2 function is wrought high, then the display knows that you're actually writing an ASCII digit to it. You can see here we've got the basic functions for writing to the digits, but right here it's the A2 is brought low, and then here it doesn't care what A1, A0 when you bring A2 low. It just knows that you're sending a control word to the display, and it's going to wait for what that control word is. Now, like I said, the control words set the attributes of the display, the brightness, whether the display is going to blink, whether you're adding a cursor, stuff like that. So we're going to write a separate function for the control word, and let's see, add it down here. So there'll be no return. I'm going to call mine set brightness. In this case, set it to 100%. And I'm running out of time here, but another thing for this brightness function, we're going to use it later on when we need to set the in the electronic prime indicator. It's a little brightness knob here to control the brightness, and we're going to use a rotary encoder, and we'll be using that brightness function in conjunction with that encoder to increase and decrease the brightness. Alright, that's it. I'll see you in the next installment here.